Now we're at a point where we're ready to take an actual image, and so I can go over here and click first I want to decide what size image I want to take. So let's say I'm going to take a 5 micron image. I look at the table here, 10 microns I can go 1 hertz, 3 microns I can go 2 hertz, so maybe I'm going to be conservative. For 5 microns I'm going to set it to 1 hertz scan rate. So I type in 1 and enter, and this is changed to 1 hertz, and then I go up here on the scan size, click on that. This is now in nanometers, but I want microns, so I type 5U. The U stands for microns, and then hit enter, and hit enter, and now it changes to 5 microns. And if we look back over here, you can see that it's picking up a lot of structure here. Let's go ahead and just go down what each of these different items means. Scan size, that's the lateral scan size. X and Y offset, usually you don't control those directly from this menu, but rather if I'm taking a large image, let's say I'm taking a 5 micron image and I want to zoom in on one part of it, I can go over on this right box and click on zoom in, and it gives me a little white box that tells me where I'm going to zoom in. So let's say if I want to zoom in on the lower right corner, I would position the box over there. Every time I click the left mouse button, it toggles between, right now it's moving the box, and if I click it now, when I move the mouse, it changes the size of the box, and I click it again and it moves it. So let's say I want to zoom in on this lower right corner. I click there, and then I right click the mouse button. That teleports the mouse pointer up here to execute, and now now when I move the mouse, it's no longer locked onto this box. So now I click on execute, and now it will zoom in. If we go back over here, we can see it's reduced the scan size down to 1.47 microns, which is the size of this box relative to 5 microns. And it has also changed the offsets, because we weren't zooming in on the center of the image, we were zooming in on the corner. While we're talking about zooming, let's discuss zoom out. Now I'm taking this 1.47 micron image. If I click on zoom out, I also get this box. It's a little bit harder to interpret. Now, this box represents what the 1.47 micron image will look like in the zoomed out window. So let's say if I click on that and then right click to teleport the mouse pointer to execute and left click, now the image I had just been taking is this, and now I'm taking a bigger image. If we go back over here, I'm back out to 4.93 microns, or almost 5 microns. I've still got a little bit of offset because I didn't keep track of the offset as I was doing that. Scan angle, right now I'm scanning back and forth. Let's see. I'm scanning back and forth this way, and if I changed it to a 90-degree scan angle, it would scan back and forth this way, or I can have the scan angle be anything in between. So that's what it looks like when it's 0-degree scan angle. If I change the scan angle to 90 degrees, it scans in the other direction, or if I do 45 degrees, then it's kind of halfway in between. So most of the time you just stick with 0. So, okay, let's continue going down our list here. Scan rate determines how fast it's rastering back and forth to accumulate the images. Tip velocity is something that it calculates by combining the scan rate and the scan size. I don't actually use that myself too much. I rely on this table to choose my scan rates pretty much, although sometimes I go a little bit slower than this if I want to get a really good resolution scan. Samples per line, normally we leave that set at 512. There's no reason ever to change that. And that's just basically how many data points is it accumulating along each line. Number of lines determines how many lines of resolution in this direction we're getting. And usually you would set that to either 256 that gives you relatively good speed, or if I click on this and hit the right arrow, it'll jump up to the next setting, which is 512, which takes you twice as long to accumulate an image, but you get twice as good resolution. Slow scan axis enabled. Normally you would want to do that. Sometimes, however, when you're doing the tuning, it can be distracting to have the cantilever be rastering over different parts of your sample, and if you disable this, then it's going to just keep on moving back and forth in the x direction without ever moving in the y direction. And so if we look on the image, you can see the image kind of looks, let me change it back to 256. The image kind of looks stretched out because we're not actually moving in this direction, even though it's displaying it as if it were. So we're just scanning back and forth over the same features, and some people prefer this mode for adjusting the feedback parameters, but I don't. So I always leave that enabled. Okay, feedback controls, we already talked about most of these. It's really only the top three that you will ever change. You may wish to write down the drive frequency and drive amplitude, although those are, of course, are recorded in the computer file whenever you save an image. Under other controls, the only one that you would ever change here is the Z limit. Right now that's set to 6.3 microns, so that's the maximum amount that the feedback system can move the base of the cantilever in Z is 6.3 microns. This system has, I think, a 16-bit analog to digital converter, and so that tells you that the minimum resolution in Z would be 6.3 microns divided by 2 to the 16th, and I forget what that is, but sometimes it's a little bit inconveniently big. So if you know that you're going to be imaging a very flat specimen, before you approach the sample you can type in a smaller value, let's say 2 microns, and that increases your Z resolution by roughly a factor of 3. It has a drawback that if you then run into something really big on the sample, you're going to crash your tip. So I would only do that, I would only bother to reduce this for the very flattest specimens like DNA on mica. So most of the time you can just leave that. Channel 1, what you type in here, as we mentioned, controls what appears in the left display. And if I look under data type, I can choose height, amplitude. Those are the main two that we ever use. Data scale just determines what the Z scale is here. So right now it's set to 20 nanometers. So going from full black to full white corresponds to 20 nanometers, and that's indicated down here where it says Z range of 20 nanometers. So I could type in 40 nanometers, and that suddenly the contrast changes because the Z scale is bigger. If I type in, let's say, 150 nanometers, then the contrast becomes even worse. If I type in 5 nanometers, then there's too much contrast. So you adjust that so that it gives you something that looks relatively nice. That's cosmetic only. It only affects this display. It doesn't affect how the data is saved.